Hi class, let's take a look at this problem right here. We have lemon imports and crash fatality rate presented to us in XY pairs. We want to find several pieces of information. Alpha is 0.05. The first thing is, what are the null and alternative hypotheses? Well, for any correlation type of test, which is what this is, it's going to be a two-tail test. So the null is going to be that the correlation is 0. The alternative is going to be the null is not 0. Okay, so there's the null and alternative. The next thing they want us to do is to do a scatter plot. So using StatCrunch, that's very easy. If I open this data in Excel, I can then copy it into StatCrunch and then work on it from in here. So go to Stat, Regression, Simple Linear. X is var1, Y is var2. Compute. And I have a multitude of information here. If I go to page 2, it gives me the graph. And as you can see, it's trending down. As I go from left to right, it trends down. And if I look at my examples here, it looks like example C is going to be the best fit. So example C is going to be the scatter plot. What is the linear correlation? Well, that's reported on page 1. The linear correlation is right here. Negative 0.985. So negative 0.985. Make sure to include the sign. That's very important. What is the test statistic? Well, in order to find the test statistic, I have to use a formula. Unfortunately, there's not a tool that's available for me that allows me to do that. So let me close that file out there and give you the formula. T is equal to R times the square root of n minus 2 divided by 1 minus R squared. Okay, and R is 0.985, negative 0.985. Negative 0.985. It's very important to remember that. And I have 1, 2, 3, 4, 5 pairs of data. So 5 minus 2 is 3. So now I can do this calculation. So 0.985 squared, and then I'm going to put a negative in front of that and add that to 1, and then divide that by 3. Okay, and that didn't work out very well. I don't have an inverse function on this calculator anymore, which really stinks. So let me try to see if I can do this as expediently as possible in Excel. So I know that the correlation is 0.985, negative 0.985. So 1 minus negative 0.985 squared is going to give me that. And then I know the numerator is going to be 5 minus 2, which is 3. And then if I take 3 divided by 1 minus R squared, that gives me what's inside of the square root. And then take the square root of that result. That gives me that. And then finally multiply this result times the R value. And that gives me a test statistic of negative 9.887. So negative 9.887. What is the p-value? Well, the p-value I can find with StatCrunch. So let's go back to StatCrunch. Stat, calculators, and T. And there are 3 degrees of freedom. We've already determined that. The T value, okay, is going to be 9.887 negative. Hit compute. And the p-value is 0.001. And again, we expect the t statistic to be, the test statistic to be huge in the negative direction or even in the positive direction. The magnitude of it, we expect it to be huge. We also expect the p-value to be super small. Okay, why? Because the linear correlation is very close to 1 or negative 1. So everything is jiving. So because the p-value is less than the significance level, there is significant evidence to support the claim that linear correlation between the lemon imports is significant. And that is true. So do the results suggest that importing lemon cars causes fatalities? Well, now you have to be careful here, okay? Correlation does not mean causation. Okay, sometimes two things can be correlated and one can cause the other. Okay, but in general, okay, the results cannot be causally connected. So the results suggest that an increase in imported lemon cars causes fatality crashes to remain the same. That's not true. Results suggest that an increase in imported lemon cars causes an increase in fatality rates. That's also not true. The results do not accept. Okay, so I think it's going to be C. There's not really any cause and effect relationship here. Okay? Thank you.